Hello everyone, this is the quite late evening update on Cyclone Dikeledi, which has now, as you can see on this infrared satellite imagery loop, crossed through the northern tip of Madagascar after landfalling on the eastern coast of the island earlier today. The storm has maintained most of its strength through landfall. As we can see, the storm has maintained most of these very cold -80 to -90 cloud tops, as well as its general structure. It appears less sheared and it's more symmetrical compared to before landfall, where we had this large asymmetric blob centered on the eastern edge. Here you can see a microwave satellite image. This is basically like a radar image taken from satellite, so this allows us to look into the internal structure of the storm. You can see that the storm mostly closed its eye wall, but however still remained open on the southern side, explaining why we didn't see the development of an eye up until landfall. Now, the big thing that has occurred since we last talked about this storm is that the HWRF model, which earlier, let me go to the previous run, showed quite a weak storm after emerging into the channel, barely reaching 970 millibars and later intensifying, has now become an absolute monster going sub 900 millibars. The cause for this rapid change in strength on the model is that the HWRF is erroneously detecting 33-34 Celsius sea surface temperatures, allowing the storm to get extreme amounts of energy. If we head over to an image showing the actual sea surface temperatures in the area, we can see they reach around 30-31 Celsius locally. This is a massive contrast to the 33-34 widespread temperatures as seen on the HWRF parent model. A more accurate model right now is the HWRF model. It maintains the structure of the storm as it goes through landfall, then slightly weakens due to land interaction and begins re-strengthening. This re-strengthening, however, leaves the storm quite lopsided due to a large amount of wind shear. If we take a sounding of the storm here at this point where it was 974 millibars, we can see there's a bit of dry air in the upper levels, as well as quite a large shear profile. Don't let this fool you, however. This shear profile is co-located with the movement vector of the storm, allowing it to feel less shear than if it were moving the opposite direction. Pretty much the shear and movement vector are co-aligned, allowing the storm to lessen the amount of speed shear that is inflicted on it. Moving on to the ensemble member output, we can see that the ensemble members have massively strengthened. We now see a lot of these pink and red colors down south in the Mozambique Channel. This shows us that despite the storm going through landfall, it has not weakened much in terms of its internal structure and is prone to re-intensify again once the conditions are favorable. If we head over to a zoomed-in version of this ensemble plot from weathernerds.org, we can see that most of these ensemble plots go way south of the island of Mayotte, which was previously in the sites of the storm, as well as avoiding a landfall in Mozambique. No ensemble members landfall in Mozambique now. Some of these ensemble members landfall again in Madagascar after a very sharp turn to the south. However, most of them head further west where they have more time over water in the Mozambique Channel, allowing for quite rapid re-strengthening. We will now also look at the HWRF model. As you can see, after it re-emerges in the Mozambique Channel, which is outlined here by the coastlines, the storm is located right below an upper-level anticyclone. This massively enhances outflow on the storm, and this can allow the storm to strengthen quite rapidly. So I would not be surprised to see a Category 3 or even 4 storm in the Mozambique Channel here. That's about it for this video. My main purpose here was to explain why the HWRF model was showing such an erroneous output and give an extra update as to how the storm maintained through landfall. Thank you and have a good night.